Hello friends, how are you? Hope you are doing well. In this video, we will try to understand the machine language in the book we are learning. So, this is our CPU. Okay, this is our processor, and these are the memory cells and the value of the memory cells. There are many memory cells, and for the program we got, well, there are just only few memory cells, right? So don't think that just these are the only memory cells. So there are many, but for our program we just need these memory cells, and these are memory cells, and these are the corresponding values of those memory cells, right? B0 value of B0 is 13, B1 is B8, B2 is H3, and go on. So see, in our CPU there are, generally there are three kind of register, like how to say, not three kind of, we should say two kind of registers, like special purpose registers. These are special purpose registers, this one and this one, and these are general purpose registers. Okay, so what registers does, actually register is kind of also like a storehouse, like memory, which can like hold data. But what a register has a specialty is, like, since this is part of CPU, so the other part of CPU, like ALU, arithmetic logic unit, can directly manipulate the data of the register. Okay, so this is how it computes the value and blah blah blah. Anyway, so okay, got it. I hope you got it. So, and this is our program counter, this is instruction register, this I said these are special purpose register. So special purpose register, so what value is holding in program counter, right? So the value of, not the value, the memory address is actually like loaded into program counter. Okay, like B0, and sometimes it can, depending on the question, it can hold depending memory at different memory addresses. So generally in questions, it will already be said that from where you to start your program counter. Okay, so if it says start the program counter from B0, okay, so get B0 here. So value of program counter is now B0. So then what it will do, it will go in, the processor will go to memory address B0 and take the first two value. Okay, like first two means like value of B0 and value of B1, and as a result these two values will get into instruction register 13 B8, and after that immediately the value of program counter will get changed to B2. And why B2, why not B1? Because see we already got the value of B1, right? This is B1 and this is B0, and we already got 13 B8 here in instruction registers. And instruction register is actually just, it's a instruction for the program language that we are, the machine language we are using, this machine language. And you can say, why just 4, right? Why just 4? Or why not one cell? Or why not more than, how to say, why not, okay. You can say that why we are just taking, two memory values of two memory cells, why not 3 memory cells, or why not 1 memory cells, or why not many memory cells at once? It is because the programming language is designed in such a way that it, you see 1 2 3 4. So the programming language is designed in such a way that it can take only like 2 byte of data. Okay, 2 byte of data. And why I say 2 byte here, these are in hexadecimal, and if you expand this in 8 bit, so this is 1 byte, and also expand this one, so you will see that this is 1 byte, this is 1 byte, so there is 2 byte. And actually this should be 0011, like binary, I mean binary, not hexa. But here we are using hexadecimal to make the things simple for our eyes or for our brain, you can say. Anyway, so see, we already got the value of b0 b1, and since these two memory values makes the instruction, so this is why we load these values directly here. Okay, and the processor is also designed in such a way that it can hold like 2 bytes of data at once. I hope you got it. So this is why we are taking those values, because if you take just 13, so it doesn't make up the program, it doesn't fit with the programming language. So as a result, and machine language, so as a result, it won't be how to say, it won't be like it won't be an instruction. Okay, so just 13 doesn't mean a instruction. I hope you got it. So so let's keep b8 here. Okay, so this is now our instruction. Right, so this is our instruction. Okay, and after loading the instruction, we change the program counter, and after that again we have to go to instruction registers and execute this value, or decode and execute. So see, this is what it called. This is called opcode, the first one, and last 3 is called operands in the machine language we are doing. See here, so there is opcode 1 here, so we also got opcode 1. So let's read the description. What is said: load the register R with the bit pattern found in memory cell whose address is XY. Okay, so it said that load the bit pattern, the value of memory cell B8, and see here we got memory cell B8, we got memory cell B8 here, and the value of memory cell B8 is 0F. And what this instruction says, load the value of memory cell B8 into register 3. Okay, so here is our register 3, right? So load the value of memory cell B8. The value of memory cell B8 is 0F. So the value of memory cell, the value of register 3 is now 0F. Okay, we got it. Okay, so this instruction got executed, and let's again go to program counter, and now we can see here B2, and go to B2 here, and see here we got A302, right? So A302. So this is now our instruction, and immediately we need to change the program counter again. So now it's B4, right? So B0, B2, B4. Okay, and this is our instruction. So what does this instruction says? Let's go here, check opcode A. Here we got opcode A, right? And it says something blah blah blah. You can read this anyway. So what does that means is the value of register 3 need to we need to do circular right shift to the value of register 3 twice time, or okay, I'm gonna show you the thing. Okay, let's see this thing here. So what does this instruction means is the value of register 3, we need to get the binary value of register 3 first. Okay, see, we got the value of 0F, which is this one, right? And then we have to shift circular shift it 2 times. This is 2, so we need to circular don't need to care about 0, because in that case we this 2 means since this is 0 2, so that means 2 times we need to do circular shift to the right 2 times. And if there is 0 3 or more than that, we need to depending on this, we need to shift our bit patterns. So this is our bit patterns, and since this machine language deals with 8-bit, so so this is why I see this is like 40 and 1111. and we just converted. It's nothing, we just converted from hexa to binary. We're converting. What we have to do, we need to shift right to 2 times, right? So that means the last two, last two value will like fall from the edge, anything like this, and they will come in front. Okay, and everything will get like shifted to the previous place. So as a result, see what happened. It was 0 0 0 0 1 1 1 1, and now last two 1 1 came in front and into MSB. So as a result, see, we got this 1 1, this 1 1 is now in front, and then we have to do nothing. Okay, so see, then we have to put just the 0 0 0 0 and 1 1. Okay, see, you can easily understand. I hope we just just shifted those values and moved them here, and now we got a new bit pattern, right? So what does this pattern means in hexadecimal? This means C3. Okay, just convert to hexadecimally again. Okay, C3. As a result, after executing this instruction, the value of register 3 now will be C3. That's what this instruction actually said. Okay, opcode A. Okay, so now we're done. So again, the instruction got executed. So again, go to program counter. It's B4. Let's go to B4. Now the instruction is 33B8, right? So okay, let's keep that aside. Okay, so okay, go to memory cell B4. The instruction is 33B8. Load it here in instruction register 33B8, and we load it, change the value of program counter B6, right? And now decode and execute this value. Let's go to here. See, what does this mean? Store the bit patterns found in register R in the memory cell whose address is XY. Okay, so now what we have to do, we need to store the value of register 3 into memory cell B8. Load the value of register 3. See, register 3, which the value of register 3 is C3, and we need to load this value to memory cell B8. See, memory cell B8. So after running the command or instruction, the value of memory cell B8 will be C3. Okay, that's it. We loaded the value. Okay, so it's done. So this instruction is done. So let's go to program counter again, and now we got B6 here. Let's go to B6, and now we found C000, right? Load it here. C0. Right. C000. Okay, so and now we need to again change the program counter before executing B8. Okay, so now let's see what this instruction means. If we go here, we will see that C000, that means halt execution, or this will cause our program to stop. So if after running this command, after our program will get stopped. Okay, so our program got stopped. Okay, then done, we have nothing to do. So this is how this whole thing works. We are taking the value of it will be set in the question most of the time. If most of the times, that from where you should start your program counter in the memory cell. So if it says B0, so it starts with B0, like B0 and go, it's not okay. Remember how we did. So then take the first value and load into instruction registers, change the program counter to B2, and then execute the instruction you got. After executing, then again change the go to program counter and see what's the value in program counter, and depending on this, again go to memory cell and take it take like now the value think that now the value is like b2 in program counter. So take these two value and take it into instruction registers and change the program counter and go to instruction register again and execute the instruction. Okay, after doing that, go to again program counter, go to memory cell, take the instruction and take and load it and change the program counter value again, right, and execute the instruction. Again go to again go to program counter and depending on this go to memory cell and take the value from memory cell. Okay, and take the value memory cell from memory cell into our register, instruction register, and change the program counter. It keeps going on. And if we found that the instruction we got is C000, that means after executing this our program will stop. Just that's it. Okay, so let's see one thing here. Here actually I was solving this problem. This is a small little problem. See, it said that if the program counter starts at B0. Okay, so our program counter starts at B0, right? See, we started at B0, right? So in first question it said what bit pattern is in register number 3 after the first instruction has been executed. And what is the first instruction? It was, since we are starting our program counter at B0, the first instruction was 13B8. I hope you can remember, right? So after executing this instruction, what happened? What happened was we loaded the value of memory cell B8 to register 3, right? And that time the value of memory cell B8 was 0F here, right? So we loaded the value of memory cell B8 to register 3. As a result, the value of register 3 that time was 0F, right? So that is the answer, that after executing like the first instruction, the value of register 3 was 0F. This is for A. Okay, and in question B it said what bit pattern is in memory cell B8 when the hold instruction is executed. Okay, so for this we need to finish the whole program until we hold, right, after running this instruction. So it just said that what the bit pattern is in memory cell B8, right, when the machine holds. So after the machine holds, we found the value of memory cell B8 is C3, right? I hope you can remember how we got into this. So before the value of B8 was 0F, but it got changed to C3 after some other instructions, right? So then we got C000 and our machine got halted. So that's it. So the answer, so the value of memory cell is now C3 after like holding the machine. I hope you understand. Okay, if you have any question you can later ask me. So the value answer of B is C3. It asked for the value of memory cell. This is why I wrote like this. You can just directly write C3 or 0F, but you should show the process. Okay, so from the next time what I will do, see an alternative version, because here we are doing the same things again and again, showing the same things again and again, but see, without doing this thing, because we don't need to take care of all of these things, and we don't need to show that where we are going every time, right? So we better organize this memory contents, address and contents like this, right? B0, B2, B4, B6, B8. So here we can see that this is our first instruction. B0 here is B0 and B1 together, right, which is 13B8. So 13B8, and then we go to B2. So now it's A302. see B2 A302. So B0 here means B0 and B1 together, and B2 means B2 and B3 together, and go on. Okay, and in case of B8, we don't know about the next value of B9. See, in our memory cell in the question there is no value of B9, so we can just keep it like that for now, I guess. Okay, and it actually doesn't matter for now. So this is not an instruction, this is just a value in the memory cell. This is actually not an instruction, but for this, see, these are instruction, and that match, since that also matches the OP codes we got, like here OP codes and 4 digits, right? Oh, okay. So what we will do next is, see, we will just leave this part now. Okay, leave this part, just think about this part. Okay, let me take it here. So now we can write, from now we can write like this, that we will just make those things from this to this, so to compact everything, make it compact, more compact. So then we just read what this machine instruction says, and then we just do what it said, and like this mathematically mathematics, in kind of mathematics way, that this code means this, right? Put the value of memory cell B8 into register 3. So as a result, the value of register 3 is now C3, right? Because no, not C3, it will be 0F, because before it was 0F, right? See, it was 0F, right? And then we'll execute this instruction, and this instruction means put the value of put the value, how to say, oh, this instruction means to whatever bit pattern we got in register 3, now it is actually, it was 0F, right? So we need to shift, do circular shift to the right 2 times, and after doing that, the value will be in same, we don't need to move this value somewhere else, we just need to go to register 3, and the value of register 3 was 0F, and do this thing, circular shifting thing, and then just keep the value in register 3. Okay, so as a result, the value of register 3 became C3, from 0F to C3. So now the value of register 3 is C3 after executing this command, right? So, and then now we got this command. What this command means? This means load the store the value of register 3 into memory cell B8. Okay, so memory cell B8 equal register 3, and which means C3. Why? Because see, we got before, even though before it was 0F, but it got changed to C3, and after that, since we are executing this command, now we will get, so now the value of register 3 is C3. It's obvious, right? So yeah, so as a result, the value of memory cell B8 is now C3. Okay, and then we got this command, that means halt or stop the execution, or stop our program. That's it. And after this line you can also write here the thing which is C3, right? Because after this command, the value of memory cell B8 got changed. Before it was 0F, and now it got changed to C3. I hope you got it. So that's it. This is how we will solve these things next. We won't do this thing again and again. This is just for basics, just to know how the things is working. And if you understand this, then you will understand why I'm taking 2 values here, why I'm jumping here, why there is no B1. Okay, I hope you got it. So thanks for watching, and if you have any questions, you can ask me in the comment section. Okay, hope you like it.